Hey everyone, welcome. Please feel free to take your seat so that I can start talking with you about AI. How exciting. um, all right. Wow, this is awesome. So, first of all, welcome everyone to the conference. I'm very excited that you're here, and I'm really even more excited that you're here in an AI talk in a C++ conference. And I think that actually tells a lot about you, that you actually see how AI is getting into things and that you need to get more knowledgeable about this topic. So I'm very, very proud of you for coming here. And thank you. So, yes, definitely. Oh, hi. So for those of you who doesn't know me, my name is Inbal Levi. I'm a speaker and organizer in C++ conferences, including this one, which I'm very proud of. So thank you very much for my co-organizers here, and to the volunteers, and to our safe space team, and everyone that have been helping to organize this conference. I'm also a program chair in CPP Now, and I'm also in the foundation that runs in CPPCon. And yeah, I already talked a lot about us becoming the second largest conference in the world, which I'm very, very proud of. Second thing, my second hat is actually a leader in the C++ Standardization Committee. We have some representatives here from the Standards Committee, which is very exciting. We have John, we have Coral, we have others in the audience, Andre. They are very, very knowledgeable people, so feel free to catch them in the hallways and get more knowledge from them, because they are the people that drive in C++ forward. But yeah, in my role, I'm the Israeli National Body Chair and Library Evolution Chair, which is the group that is in charge of the standard library. But today, I'm actually here on a different hat. So I'm a C++ developer, but I also, Andre, I also joined Microsoft around a year ago. And I'm sure you'll know how Microsoft is keen about AI, but I have to tell you, I was skeptical at first. I've started looking at AI around 2 years ago, I think, more or less, periodically, like every now and then, checking how things work. And I was skeptical at first. But I have to admit, after joining, and 50% of my role these days is to develop and deploy tools for C++ developers. So I'm not in the Copilot team. I'm not one of the people that developed the model, but I will definitely tell you everything that I learned about how C++ developers can use those tools. Because the role I'm actually at is the Windows security team. Okay, so this is my official job, is to develop security features for Windows. But officially 50% of my time is dedicated to developing those AI tools and deploying them among our group. So I am very excited that you're here today, and I hope that you learn a thing or two, or for the very least, get more excited about AI, as I was skeptical at first, but I hope you will change your mind later. And last thing that I want to say is that opinions are my own. Again, I'm not representing in any way Microsoft or the Copilot team. Of course, I'm not there. But also, this is from internally deploying tools and my experience. Nothing been processed here. So why should you care about AI? This is a graph showing from 2017 to 2024, the responses of people saying that at least one utility in the organization is using AI, right? So around 80% of the organizations are using AI these days for at least one functionality. And I'm sure this does not surprise you. If you are working in a tech company, even if it didn't get to you yet, it's going to get to your teams, to your work processes. And that's why I think you're here, right? You recognize the fact that this is something to reckon. This is a force to reckon, right? So again, I think traditionally, C++ developers and a lot of the community sometimes is embedded developers, people that work on systems that don't necessarily get the latest updates. That's exactly why I think it's important for us as a community to move forward, to be in the front of these new tools and revolutions. And I'm not gonna advocate and try to convince you that this is the largest revolution ever, because actually I don't want to predict anything about the future. But I do want to tell you that this is something to recognize and something to take under consideration. And that's why, again, I'm very happy that you're here with me today in a C++ conference, despite the fact that the community previously have been considered as late adopter for technologies. Today's market for AI is around $250 million. Anyone wants to guess what is the prediction for 8 years from now, in 2033? Just throw numbers. Maybe try to guess in percentages from the world community, global, sorry? Third, wait, third of the production of world is gonna be, 33% is gonna be AI? No, that's too much. Talking about the global economy. Try to go a bit lower. 10x, right, 10x, that's good. That's actually very, very good. Yeah, so we got here a knowledgeable person basically expecting 2.5%. That's actually quite true. $3.3 trillion, which is between 2 to 4% of world economy, is expected to be either directly from AI or related to products that come from AI. And this is huge, right? And I'm sure you're not surprised, right? You see how AI gets into every aspect of our lives. So what I say is, let's tackle this, right? Let's get to know this first. So when I was trying to get into deploying tools, and I will remind you all that I have not worked, at least not as officially part of my role with AI before, with developing tools for AI before, I've started getting to know with a lot of different terms, right? So there's quite a lot of things flying in the world for AI. How many of you, okay, so with raise of hands, how many of you know at least 5 names that are on the screen? Okay, keep your hands up. Okay, that's pretty good. How many of you know at least 8 names on the screen? Okay, that's good. How many of you know 13 or so? 12, 13. Oh, wow, okay. that's less. How many of you know 20? I guess you're lying because it's not 20 things here. But yeah, that's close enough. Well, that was quite a lot of hands up. That was very impressive. So I'm very happy to know that I'm talking to an audience that is knowledgeable about this topic. But when I got into this, there's so many technologies coming up, right? Every day we get a report on a new model coming up, and what I want you to take from this talk is not necessarily a specific technology. What I'm trying to give you here is actually a way to kind of have a broader perspective of how AI tools work. So there's 3 types of interfaces, and I'm sure I'm not telling you any news about here, but we have chats, right? So I open some web page and I start chatting with my bot and I get information. We have development tools, things that are running in our IDEs, in our CIs, right? Copilot, etc. And we have agents. Agents, so the terminology for agents is not well defined, I would say. Like people come with new definitions now and then. But generally speaking, agents would be something that runs and do work automatically. But here in this talk, I'm actually going to focus on development tools because I think this is what's important for you as developers. And also, I'm going to give you a hint that once you're able to control those, to use those productively, it will be way easier for you to move to agents world with your tools that you're going to get. So AI workflow. How does AI workflow work for development tools? So I have here developer, right? In this example, it's VS Code. Specifically, my favorite tool is VS Code. So I have here a developer. And the developer asks a question to the LLM, right? Generate a student class with these member fields. So the LLM needs additional information, right? If I'll just ask this question, what is missing? Things are missing, right? Like, for example, which software developer, programming language is it? What is a class in general? Maybe it wasn't trained on this information. It needs to do more things to understand my question. So it can look at my files on a computer, and it can also go and do some web searches, or if it was trained on the data, which clearly is not going to be up to date as things going on web, but it can actually get more information. So I need more information. Then it gives me back an answer. But this answer is not living by itself, right? I need to basically plug this into my code, right? I have a code base, I have a structure of my project, and the LLM needs to be able to actually inject things into my project, like create files. So generally speaking, this aspect of the flow I would call the LLM or the brain or the model. This aspect is the context, and that is very important. And this aspect is the tools, right? So the LLM have kind of implementations, tools that is being provided in order to inject things into your code. This is not coming out of nowhere. Developers have worked to develop those tools so that LLM can basically spot the place in your code and then inject information there. Right, so now we know how those things work in general. I want to introduce you to, for example, some work environment, the specific one that I'm using to explore. But again, this is not an advocacy for any specific technology. What I want you to take from here today is being familiar with the fact that there's a lot of those things flying around. So specifically, a VS Code environment, I'm using WSL to compile, or sometimes if I compile Windows, it's a different thing, of course. And then I have those extensions. So do people recognize the extensions? It's actually a hint they're written, but what is this one here? Hope you can see my, yay, it's actually Klein. C-line is, C-line is an IDE. Yeah, that's very overloaded term. So we have Clang, we have C-line, and we have Klein. This one's Klein. What is this one? Do you recognize this one? The kangaroo jumping? It was a lot of hands up before. Go ahead, just shout the name. Ooh, that's rude, thank you. Which one's this one? That was a good guess. That was rude. This one, the one that looks like a stain. That's yeah, someone said that. Cloud Code, cool. That's the extension for VS Code. They also have a CLI tool. What's this one? They actually modified their symbol, unfortunately. I like the previous one better. Copilot, right, yay. Okay, yes, so you are knowledgeable. That's pretty impressive. So yeah, we have different extensions, and I want you to see those as things that you can, as replaceable, because I'm not here to tell you use a specific technology, I'm here to tell you explore. So let's start with our exploration. So we have the different extensions. I already mentioned that Cloud Code have a CLI. By the way, Klein also added the CLI just recently, just from the latest 3.3 version, which is pretty cool. And now I have my extension open. I have my Klein open, for example, and I want to configure a model. So I'm doing this using a provider. People here know what a provider is? LLM provider? Okay, cool. Well, okay, so basically a model, right? And I'm going to talk a bit more about this later, but think of a model as a black box, like a website. And as you can run a website on different servers, like you can run the same code, the same website on different servers, in the same way you can run a model coming from different providers. So basically, here specifically I use VS Code LM APIs. This is like Microsoft set up a server that runs this model, GPT-5, and it provides you with the answers. But I could also go to Microsoft servers and get answers from Anthropic's model, Claude. And I can also go to Anthropic and get answers from other models. And we also have providers that are generally providing all the LLMs. So again, think of it as a website that runs on different servers. So when I choose, generally speaking, when I talk to ChatGPT or when I talk to Claude, that's maybe a better example, I don't necessarily talk with the same exact model, because it might be, if I go through the provider from Microsoft, it might be that Microsoft have set up a server, and now you get answers from this model from Claude that runs on Microsoft server. And it might be that it's an open router endpoint that you get answers from Claude. So the model is the same, but it can run on by different providers. And this is important, and I'll tell you later a bit why. But generally speaking, the models are the same. Still doesn't mean that every time you reach to a ChatGPT, you reach the same endpoint on web. Okay, so now I'm doing the most basic thing, and this is why it was important for me to give this talk, because from what I've seen so far, and I actually think that people are doing a great job in trying to get AI into the C++ community, and I've already seen a few very, very exciting talks in the latest CPPCon 2025 by Jason Turner, by Daisy Holman, by Matt Godbold, by the way, it is in charge of the website, yes, the one that you're thinking of. There were very, very good people in the C++ community talking about AI. But I've noticed that mostly people are talking about what happened when you open your environment and you try to talk with the LLM, with the model. But I want to take us one step further. But before we move to next steps, this is the basic setup, right? So I open my setup, I open Klein, I have my ChatGPT through Microsoft provider, and I'm asking a simple question. Can you add login to my code? Okay, so what do people think that's going to happen? Just shout, that's fine. Yes, really. You're a very optimistic person. This person on the first line is very optimistic. What will happen? What, sorry? This is a plan mode. It's okay, so there's two, specifically in this extension, there are two different modes, correctly spotted by this person over there. There's plan and act. So plan generally, specifically for this extension, right? It's, so plan is basically the mode on which the LLM is basically collecting more information, data, and then you move to act mode, and then it actually executes. Okay, I'm going to give you the answer. So the LLM is doing the reasonable thing. It goes in and it tries to read my code base, which makes sense, right? I need to collect the context that we mentioned before. You can see here 16K of tokens, right? I only asked one sentence, right? Can you add login to my code? It's approximately 6-7 tokens, right? But it actually have 16K tokens already been uploaded. What does it do? It goes and it reads my code base, which makes sense, or the whatever files that it finds fits. And then it asks me questions, right? Because logging is not well defined. Like what am I asking? This is very general question. Add login to my code. Do I want to use some common library that's been used in the industry? Do I want to add macros? Do I want to add a class? Do I want to log into files? It's actually asking. It gives me multiple answers, suggestions. And that makes perfect sense, right? So I didn't give it enough context. So what would be the next thing you'll do? When you get this answer, what will you do? Like just, you people have worked with AI tools. Choose, right, give more details, right? Start chatting with the bot, chatting with the extension, trying to give more detail, more context on your intention of what you want to get. So we're here today to not make you do that much and help you save time. So that makes sense, right? The model is asking you for more context because you gave a minimal context. So you have the extension, you collected information about your code, but you haven't actually told it things like your preferences. Do I want to use macros? Do I want to save to files? Things like that. How do I want my login to look like? And there's a lot of options out there. So again, just to summarize what happened here, I asked the model, can you add login to my code? it recognized that I'm in CPP project, right? Because it read my files. It recognized that there's no logger in my project, which is also important. If I already had some logger header, it might have just went in and start adding instances, which makes sense. But it recognized that it's not there. And then it also did some searches to kind of understand what's the solution space. But it told me back, I need more context. That makes sense. So now I hope you now start to understand where I'm getting to. And I'm trying to give you tools to break those flows into parts so that you can improve those different parts. So we have here 3 major parts that have been participating, right? We have the model that I've reached out to. We have the environment, like for example, the IDE, the VS Code in this case. And we have the context, right? And the context can be files, or it can be some things like asking more questions from the developers so that it can get better answer. So now let's break those and try to get a bit more familiar with each of those parts. So the first part is the model, and I'm going to go over this really briefly just to make sure that we're all on the same page. Model is the brain that's processing your requests, okay? And LLM are basically language models. So what they get in is tokens representing a sentence. What they give you out, what goes out, is words. Completion of words, and this is very important to keep in mind. So there's no, for generally speaking, right, I'm not talking about like more specific things like image processing, etc., but generally speaking, when you write code with an LLM, it gets in tokens and it gets you out tokens. General architecture is neural networks. By the way, there's also small language models, the ones that can run on your phones, not just the request run on your phone to some other place, but actually can run on more lighter weight technology. And when I add login to my code, this has been translated into numbers. Those numbers represent words, and this has been injected into the model. What I get out is other words, for example, the questions that it asks. Here are 5 options. So this is just what it is, right? There's no deeper meaning in the answers that LLMs give us. It's just that. When I talk about model, I'm talking about those numbers that represent those nodes. So those are statistical, like the chances for getting a single word or specific word considering the input that came in. And when I talk about ChatGPT model, I'm talking about those weights. So all those that I've marked, they have numbers. And if I have this architecture and those numbers running, then I can reproduce the answers when I run GPT again on a different server. But again, keep in mind, this is not deterministic, right? So I could get different answers. And provider is, just as I said, the server that runs the model. So again, I encourage you to go and watch Daisy's keynote, Crafting the Code You Don't Write. And she's actually working in Anthropic, recently joined, and I think it's really exciting. She gave a talk in latest CPPCon to learn more about models. So now let's move to the part that I find more interesting, context. So models basically, as I said, read text or images and get you output. But context is everything that's added to the request. So I had a request, add login to my code, right? But you actually can have context that is either per a specific run or immutable, per if I close my IDE and open it again and reach the same model, I give it the same context. For example, the project files that I have, system prompts, which I'm going to talk about a bit later, those things are immutable. The mutable parts are the specific answers, because if I came up one day and I asked, please add login to my code, and I'm very, I'm very busy, I have a lot on my mind, and I don't have time to write a very specific answer. So I might just tell something, I might answer the LLM something like, just add login however you see fit. But on different day, I might give it a very, very detailed answer. So this is immutable, right? In a sense, it's mutable, right? In a sense, it really depends on the run and the specific time that I've tried to create it. So mutable context, as I said, is like answers, even chat questions, those things that are not consistent between runs. Specific LLMs can look at different files. Like, for example, I have a code base with 10,000 files, and maybe the LLM chose to look at specific files during this run, but maybe different files during another run. And it's very important to kind of identify those. Results of searches. So those things that you can't control as a developer, because you don't know what would be the mutable context that the LLM would use. But what you can control, and I think you should, is the immutable context. So immutable context is things that can be split into two things: project-specific context and global context. So what is project-specific context? Did people here heard about Klein rules? Files. Wow, 1 or 2 people, all right. Did people here heard about memory bank? All right, awesome, cool. Okay, that's pretty good. Okay, so generally speaking, do you remember what I said before? Models read text. Generally speaking, models prefer to read markdown files. Don't ask me why. And there's different ways to feed those markdown files in different extensions to your model. So things like, for example, Claude markdown files. So this is for the Claude extension, for example, or CLI tool. It knows and it cares about reading the content of this markdown file, predefined name, right? Klein rules. This is a file, a markdown file that the Klein extension cares about and goes to look at, right? For if you've opened this specific extension, you'll go and look at it. Copilot instructions markdown file, sorry. So all of those things are different ways for you to feed, to inject more context to the model for your specific project. And the way to use this is to write those files and then commit them to your project, right? So if I have a specific project, for example, that I've been working on with my different team members, and maybe they're 30 team members, and I don't necessarily talk to them, and maybe there are hundreds. But if I commit those files into the project, it's a way for me to kind of share knowledge between all those teams. And whenever someone would git clone this project, they're going to get those files along with the project and going to get all this context for the LLM. So next time they're going to open their RDE, even without me telling them anything about this, they're going to know what my preferences are for logging. This is powerful. Another thing that's been mentioned here is memory bank. So memory bank is a protocol described by Klein, by people that worked on Klein extension, which, by the way, is an open source. And this is also a way to basically inject to your project information. So let's see how this works. So here I have kind of a basic, very minimal project that have a main function and student classes. And I don't expect you to see all those, don't worry, you don't have to read from there. So I've added a memory bank into my project. And memory bank structure is as follows, and it doesn't really matter because everything is, of course, online under Klein's information. But we have predefined files, and the LLM is going and reading those files before it gives you back answers. So I've created this memory bank, and again, you saw what the LLM answered before. It basically asked for more context. Now I gave it context. I gave it context on specifically how do I want my login to look like. And I even gave it a class. I'm not going to show you the details of it, but I gave it a class telling it how exactly the login should look like. If you don't have it, add the class. Otherwise, just create instances and log. Pretty reasonable. So let's see what happens. So first of all, here I'm showing you the tech context markdown file that I added and committed to my project. And now I'm asking the exact same question as before. Can you add login to my code? So first thing that's going on is the LLM reads the project data, which makes sense. It goes and reads all the files. Cool. It gives me some plan of what it's planning to do. And now, on opposed to previously, right, this is important, it was not clueless. It did not tell me I don't know which option to choose at all. It had some information on how do I want to add login to my code. And all the difference was I added this markdown file. And now it's not just for me, right? If I committed this into the project, the person in the next room whom I never talked with would clone this repo, and when it asks a question, it gets this knowledgeable LLM adding login to their code. So it did recognize some things like the levels of logging that I'm not gonna, by the way, all this code is committed into my GitHub, so feel free to go in and look at this, but I told it in the instructions to use login levels, and it did go on and did that. But it still has some open questions. It's not sure how to basically, it's not sure where to add those logins, etc. But it's still more knowledgeable than we saw before. So a few questions still. Let me just continue this. But already not helpless. So now I'm moving to act mode, as I've mentioned before, specifically for this extension. Planning is one mode and acting is a different mode. And it now generates the logger file that I don't have in my project, and it generates it according to the rules that I've added to the client, to the memory bank markdown file. So already we get something more to the line of what we wanted. And now it's adding logging. So I would tell you again that specifically, I'm not very happy where it picked the login places are, and I did give it specific instructions of put login only in places that are significant in terms of flow, in terms of functionality. But it's better than before, right? So we have something. So I talked about project-specific context, and again, think about the usage of that. That's very powerful. I now want to talk about global context. So instead of for a specific project, and you committed this markdown files into your project, you can also do this in global context for your IDE, for your environment. So similarly to all the files that you've seen before, you can commit them into some predefined places on your setup, on your environment. And that means that every time I open a project, I have a login preference for all the projects that I'm working on for my company. It's not just for this specific project, right? So every time I'm opening my IDE and I have these committed files, LLM knows better about how to log the code. And there's also things like modes and personas. So this is something that comes from Rue. They're actually the ones that kind of promoted this. People are familiar with personas? Did you hear about those things? No, okay, so what is that? LLM, and this is very, very interesting, and Daisy actually mentioned that in her talk as well. Context of who is asking the question is important. So in a sense, a way to really improve answers by LLM was instead of just writing the question, writing something like, developer asks LLM, please add login to my code. LLM answers, ... And that was the improvement. Because again, as I mentioned before, this is only processing text, and it processes text better with more context. So specifically here, mods or personas are a way to kind of inject a predefined role to the LLM or to the model. So in Rue, you can see this, and also, by the way, in Copilot chat, you can predefine roles, like, for example, an architect. So if you define the role architect, which is, generally speaking, someone that cares more about the project flow, about the architecture of the project, and about the technologies, and you choose this role, and then you ask the LLM a question, and again, this is all in the extension. You just pick this, install Rue and see this, or Copilot and see this in the extension. You get different answers, because now the LLM have different contexts. It thinks differently on things. And you can also, by the way, do this specifically for your project or company. I could define the role or persona that is a Windows developer. And specifically, and I'm sure you're all guessing, in Windows, we're doing things a bit differently. Maybe we're using specific format of events. Maybe we're using different debugging options. But these are the things that I can predefine. And now, every time I open my project and I use this persona, this LLM answers, but with the additional knowledge of the ways I do things. last thing, or one before last thing I want to talk about is system prompts. So all the different extensions that you've seen, they all, if I can pick in all the extensions the same model to go to, and let's ignore for a second the providers, because extensions, you can choose different providers from different extensions, but let's just say that I go to the same provider from different extensions. Would you get the same answers? Let's raise hands. How many people here think that if I'm opening Klein and pick up the Microsoft's provider, the VS Code provider, and go to Claude Sonnet 4, just throwing names of a model, and I'm asking, can you add login to my code? And if I'm doing the exact same thing from ChatGPT extension that you've seen before I have on my workplace, going to Microsoft provider, running Claude Sonnet 4, and asking this question, will I get the same answers? How many people think that I will? I do ask this question, so, oh wow, okay. I really hinted you. Okay, so no one thinks that I'll get the same answer. That's good, you've been listening. So there's difference, right? Because the difference with the extensions is what the developers that develop the extensions have put into the context, and this is the system prompt, and we're gonna see an example later, but it's not just that the question goes there, right? We saw the 16K tokens. Those are collecting information about your environment, and they're collecting them differently between different extensions. And last thing I wanna mention in global context is MCPs. So how many people here heard the term MCP? Oh, wow, awesome. Okay, what is MCP? Shout. Model, context, protocol, right? Okay, cool. I hope you can recognize the kind of similarity to what I've keep focusing on. But yeah, this model, context, protocol. So this is protocol for providing more context to your LLM. And this has been created by Anthropic, but it's actually quite spread industry-wide. And I've wanted to show you here how we're using MCPs to improve the results of what we got so far. So I'm doing the exact same thing as before. Cool, I have 22 minutes. That's actually pretty good on time. I'm doing the exact same thing as before. Add login to my code. I now connected an MCP. Again, everything is on GitHub. And this MCP knows about logging. And I basically copy-pasted the exact same text that I had on the memory bank, on the markdown file, to this MCP. And I get it back from a resource. So let's see what happens. So first thing that happens is that the LLM recognizes, I see an MCP server. It's called login MCP server, right, because it's connected to it. And it now goes and calling a specific function that tells it more about how do I prefer my login to look like. Next thing is, as before, read all the resources, read everything that is in this MCP that talks about logging. And I injected to it 4 stages. Create logging, identify login points, implement logging, and summarize to the users. Okay? All of this we're gonna go over later. So let's quickly see what happens. So after what you saw, it went to the MCP, it read the steps. It now specifies the steps that it's planning to do. It goes and reads the entire code bit just as before. Now it creates a logger HPP file, but this HPP is exactly what I've told it I prefer to have in my preference, in my guidelines. So this is more accurate than before. Okay? Now it gives me a file that I've asked it to provide. It's called login suggestions markdown file, and it tells me where it plans to add the logging. I want you to notice everything I'm doing here is click save and accept. I did not feed any additional information after running this initial prompt of add logging and connected it to the MCP. And now I got additions to main, and I actually kind of prefer those. Those actually telling me when the application started and when it ended, as opposed to what previously been added, which was also the login level and other meaningless, in my opinion, information. Now it goes and do the same thing for the student class. Again, I think it's doing a better job in adding logging. And I would encourage you all to download this MCP and try to exercise it on your code. Last thing it's doing is removing the login suggestion markdown file because I asked it to. I told it, like, create this markdown file, write all your suggestions, then remove the markdown file. It's doing this by itself. And then it summarizes. So I think, let's see what else here. I think it's pretty cool. Now, I know who I deal with because you're C++ developers, so the next thing I did is, without correcting, without doing anything else, I told it compile and run. Compiled and run. By the way, I could add this as an instruction. I just wrote this in the chat. So it compiles. There's CMake infrastructure in this project, as you all probably know familiar with. And it ran. And you can see here, application started, application finished, and we didn't create any students, so it didn't have logging. So I think it's pretty cool. And you remember where we started. We started with asking the LLM to do something. We gave it context, and we improved the way it worked. And now we give it context in a different way, in a more structured way. And all we need to do is approve. Okay, it's pretty awesome. So this is where I tell you that in Microsoft, what I did is something very similar, but instead of 4 steps, which is in this demo, 16 steps of adding events. Me and the team, we've worked on these servers, and it's not a single server, but an infrastructure of them. And from opening the code, adding events, processing on database, the processing required creating a Python notebook to process between one format to another, committing that into pipeline. The pipeline ran, processed the data, went into a more long-term database, and then created a dashboard. Everything by writing one sentence, not even telling it, hey, you have an MCP, but writing one sentence and getting the output. Any questions so far? Yes. Oh, sorry, I need to repeat your question, but also, what's your name? Shaked. Hi, Shaked, please. Yes. Okay, so Shaked asked, what's the difference between MCP, memory bank, and MD file? Okay, so markdown files, generally speaking, the LLM reads text, and it reads, when you commit markdown files into your code base, it goes and reads, or sometimes you need to trigger it, depends on which extensions and what the predefined agreement. If I run with client extension, for example, it have predefined protocol that's called memory bank, and it will go and read those files. Now, markdown files in general, like if you'd have documentation, if you had README for your project, and sometimes you need to trigger it, but most likely it will go and get the context from those files. MCP is a different thing, and maybe I should have explained a bit more about this. MCP is actually a server that provides answers to, it's an endpoint. So basically what I've shown here is a local MCP. It runs on your local host. It's a Python server, and it have predefined functionalities. So the functionality can be either resources or tools or prompts. This is just in the protocol that have been defined. And those functions, LLM, being loaded to your environment, right? Sorry about that. Okay, let's see here. So I open my extension. Sorry. I open my extension, and if you can see here those lines, I've set up this MCP, and it means that whenever I open my IDE and I open the extension, this MCP that I've set is actually being ran on localhost and answers the LLM's questions. So first thing, the LLM what you got from this is that the LLM went and asked, it recognized that it have an MCP that talks about logging, and went and asked for, can you give me information about logging? And this is exactly what you see here. This is the call for the function from the MCP, get logging info doc. So this is like, give me the general, all the information that you have about this. And by the way, this is not trivial as well, because one of the things I needed to do is explicitly tell the LLM, like by documentation and by naming and by other things. That's a very interesting aspect as well. By the way, LLMs read documentation way more than you. But I explicitly marked this function as a mandatory function for the LLM to read whenever it wants to add login. So LLM, extension being loaded, I write this sentence, can you add login to my code? And the first thing that happens is the recognition of the MCPs. We're going to see this. And then the call to this function that I highlighted as the information source. After this information source been read, the answers are going to be completely different. So I hope I cleared that up a bit. Cool. Yeah, and by the way, I just want to emphasize, I'm not advocating for any specific technology here. I'm telling you, go and experiment, because it gives different results. Go ahead. Yes, what's your name? What's your name, sorry? Sergey. Hi, Sergey. Yes. Right. 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 So Sergey is asking a very good question. If I copy-pasted the things from the Markdown file to the MCP, why did it give it different answers? So I can give you, I'm not a developer, I'm not a data scientist, I'm not developing LLMs, but I can tell you that most likely MCP is, so it really depends on where do you put those instructions. If I'll write something like on a function, if I write something like call this function to give me information or something, it's a completely different thing than if I write a function and then on the documentation write something like this is mandatory, don't start anything from the process before doing this. Because the context matters. So my assumption is that when it was in the Markdown memory bank file, it was not seen as kind of mandatory instructions, as kind of as kind of a forcing. It's different between if you ask your colleague, how should I implement those loggings? They will tell you, look, there's multiple options. I think this one's nice, and I would go with that. Between this and between your colleague telling you, we only do it this way in this company. So I think that's where it came from. But I'm not an expert, so I can't. I would recommend, personally, I would recommend try both options. If one thing that I want you all to take from here is that it's not costly to move between them because the development times of those things are pretty light. Let's take a bit more questions and I'll do my last 10 slides. So let's take a question from here from someone from Mobileye. What's your name? Hi, Uriel? Ariel. Hi, Ariel. Right. Right, so first thing about providers, quickly. So first thing is the cost. So for example, I work in Microsoft and we get free, sorry, let me see if I can actually jump there really quick. Sorry, I probably should have had more of those open. So, yeah, so I get, never mind, I can't find it. I get free or very cheap access to tokens from models that Microsoft runs. Again, not just ChatGPT, but also Claude and Gemini and others just come from this provider. So first thing to consider is the cost. Second thing to consider is responsiveness. Like, for example, if I, for example, for exploration, I have an account in Anthropic, I have an account in Klein's providers, I have also, of course, Microsoft, and I have Claude account, and I do exploration because I want to see the answers. But it basically depends on those things. But one thing I think is cool to know about this, and is actually the purpose on why I showed you those different providers, is that moving between the models is easy. I think it's worth your exploration. So it's not, what I'm trying to emphasize is not necessarily try different providers, but try different models, okay? So this is really the point here. Okay, let's continue. All right, I'll continue with questions at the end, but I do want us to go over one more part. framework. So I've been jumping in and out from those, and I've been mentioning different extensions. I've mentioned my personal environment that I like to explore with and research with, which is the VS Code one. But there are a bunch of different, there's a lot of different ways to reach out and engage AI today. So I want to mention a few others that I haven't got into deeper here, but I want you to explore, is Cursor. So Cursor, for example, is a fork from VS Code. So they basically forked the code base for VS Code, and they've developed IDE, which is paid IDE. It's not open source. And it's basically setting up the system prompt, the environment, everything that we've talked about differently and giving good results. We have the VS Code that gets different extensions. You have Claude CLI, for example, which is a CLI tool that you can run on your environment, and you're setting up differently with Claude MD Markdown file, for example. So there's really a bunch of them. Of course, JetBrains have AI assistant in their IDEs as well. So there are really different frameworks for doing this. But I think that's actually useful information here is to know that you could take the context that once you identified correctly the context, you can take those between the different frameworks and different extensions and move between them and test, and you get to recognize the one that you like to work with best. So I want to dive a bit deeper into the difference between those frameworks. So here you see the client extension again, right? And I've asked the question, can you add login to my code? And I briefly mentioned things like system prompt or environment. So what does that actually mean? What happens is that the extension, the developers of this extension have decided that some specific information is useful for the LLM to answer. And this is the 16 case that we've seen. So this information includes, of course, the task itself, but also things like to-do list. This is not, I didn't write this in chat, right? And it's not something coming from the LLM, it's something sent to the LLM. So this is client developers saying, I prefer, when you ask this question, here is the additional context. We have environment details. We have which visible files, which files are currently open in my IDE, right? This is important. Maybe I care about these files. We have location, etc. We have current working directory, which is very interesting because, again, remember that the LLM injected files into your code because it needs to learn from somewhere the structure of your project. All of those things are things that are added by the developer of this specific extension. So if you open Copilot extension and you ask the exact same question, those additional metadata that would be sent is going to look different. And this is the power of the specific frameworks. So there's a bunch of them. I've mentioned, yes, sorry, what's your name? Yigal, yes. Yeah. This is the client, right, so again, this is the client extension. So consider this process. I opened client, I figure out here ChatGPT-5, I figured the provider, I didn't write anything yet, and then I write a single line, can you add login to my code? Instead of sending just, can you add login to my code, client is creating this file that you just seen, and it's right. Yes, exactly, and this is the API request. So the actual API that your actual request that you're setting to the LLM is not just this line, but everything that you just saw, and this has been defined by the client extension developers. So the same thing goes for Copilot. This is the power of the framework. Exactly, and that everyone here answered correctly. Not a single person said that they're going to get the same answer. And that's one of the reasons, because the difference is on what am I sending to the LLM. It's not just the randomness of the LLM itself. So I'm 5 minutes from finishing, and obviously I could never show you everything that currently exists in the AI world, but I do have blog posts. I have 2 of them. And they're talking, first of all, about the structure that you've just seen here, the model, context, and framework. And the second part is listing AI tools that I've basically worked with or explored, and their purposes, and what are they doing, and what are they good at, and what is the usability, etc. So I encourage you to go and look at them. And we have things like chats that I've mentioned before, so Copilot and Claude Chat, etc. But we also have no-code extensions for creating agents that may be interesting as well for some of you or for people that you're working with. We have the, and again, as I'm C++ developer and I'm focused on developing tools for my group, I'm focused on the C++ developers frameworks, but there's, again, quite a lot of them. And of course, prepaid and paid IDs as well. So I also want to emphasize frameworks are very different in the scale of UI, of whether this is meant for giving answers to the developers as they work, or automation. So now we're trying to, starting to touch a bit on agents, but we'll talk about it very briefly. And also, frameworks are different in which context can you configure. So, for example, chats that you open in your Windows in the browser, they are not fit to fitting in immutable context, right? So basically, they sometimes preserve information about the session, about who's connected to them, about previous searches. But you don't basically feed your entire code base there. It's not fit for that, right? But some extensions, for example, the extensions in the IDE, are better fit for actually reading things like your code and the files that you've opened. So I want to summarize, and I want to tell you what to take from here and why it was so important for me to tell you about those things. Because it's not because I was trying to advocate for a specific extension. That is definitely, or a specific tool. That is definitely not why I'm here for. I'm here for you to be able to find your way in the flood of AI tools, models, frameworks, technologies that coming up our way. And once, in my opinion, once you can recognize which parts is it a new model? Is it a new way to feed context, like MCP? Or is it a new framework that gives you the system prompt and the environment differences? You'll be able to move between those different tools, different technologies faster. And that's why we're here for, and that's why I hope for you to take from this talk. One last word is about agents. So there are different frameworks for agents that I haven't talked about. But everything you saw here, for example, MCP, and context, by the way, in Markdown files, can pretty easily be plugged into agents. And this is the power, this is at least the way that I recommend for you to work in. Start with configuring the context, the MCPs, the different ways to your LLM. Test this on your environment, and then take those texts, and again, LLMs reads text. That's what they do. They don't do anything other than that in terms of giving you good answers. So take those texts and feed them into your agents, and there's ways to do this in the frameworks. And that's how you basically develop more automation. But I want to give you an example for something that I did for a talk about reflection. So for those of you who are not familiar with this, reflection is a feature going to C++ 26, which is exciting. And I was wondering, why do we need code generation features if we have AI, right? So in this example, serializer. So this is without any additional context, just like the chat in my environment. And I'm asking it, sorry, I apologize. And I'm asking it to add serializer to my code. So first attempt, I get different input and output types between the serialized and deserialized function. Next thing that I got is memcopy, which I'm sure you're all familiar with. Not great when you have things going on in your constructors. And last thing is that I got, like, for example, this deserialization function returning my type, and without the ability to recognize that this was not correctly serialized, right? Because I need an error handling, kind of an error report way. And then I did the same thing again, and I got a very different answer. So that's where the non-deterministic aspect is coming in. So I want to emphasize that AI is not automation. And this is very important because people confuse them a lot of times. And what it creates is the kind of false assumption that I can write an LLM and I can configure my LLM some way and it's gonna run and it's gonna work this time. And now I can plug this into some CI and it will work. But that's not the case. If the results are important for you, you need to use other tools to verify the consistency of the results. So in a way, instead of UI focused, I would say there's also a scale of automated versus inconsistent. And here are some ways that I've learned to increase consistency. So ordered instructions are very, very good with helping the LLM creating consistency, going back to the instruction and checking. As I mentioned, we have a process of 16 steps, and the best way to make sure that the process is continuing, again, not to remind the LLM to continue with the steps, but to, in the instructions, tell it, go back, verify that you've executed the step, then move forward. If you need to verify that there's a process going on, do things like insert instructions, go back and check. Separate roles, for example, use some supervisor that goes and check the other results of the other LLMs or the other agents. Inject determinism by, for example, MCPs. I didn't talk about it very much because I didn't have time, but MCPs have what is called tools, and tools are deterministic functions that you can call, which is different than just asking the LLM to do something. So, for example, if I write in the chat, please add 2 plus 2, most likely I'll get 4, but there's some chances of which I might get 3 or 5. And if I use a tool if I provide a tool that's called add, and the LLM with an MCP, and the LLM puts 2 plus 2 in the add function, this one's deterministic. So this injects us more determinism to the process. Client's workflow is another feature that I didn't talk a lot about, but it's basically a way to give the LLM kind of instructions of how to do things in order. And those things are important, especially if you're looking for automation. And last thing that you can do, and that's like the heavy hammer, is create some feedback loops. So you can generate code with one LLM and then try to ask a different LLM or try to tell it either within the same instruction files, verify, check your result, or you could have a separate LLM running and checking these ones. So creating those feedback loops also increase determinism and increase the way to have your output be more expected and according to order. And Jason Turner in CPPCon 2025 also gave a bunch of really good hints or suggestions. And also I would recommend you to go and watch the panel, what we learned from working with AI. So I'm really past time, so I'm just gonna go really fast and tell you the main takeaways. So stage 1, capture the information that is important to your project in writing, because LLM read text. Okay, so write this in a markdown file. Write this if you need, move this to an MCP, do whatever you need to feed this into the LLM, but capture what's important to you in writing. Verify, which context is the one that is consistent between your project and consistent between in the same project or in between projects, and put that in writing and verify where it is. feed the knowledge into your framework. So pick a framework, whatever framework you're picking, but feed in the knowledge. And if you think that it's enough, do a circle of tests, but then maybe add more. Correct the text, correct the information that you're feeding. And identify, that's important, the things that are constant and the things that needs to last between projects and things that are only relevant to this run. Do iterative improvement. So run those things, do your testing, see if you get the correct results. If you don't, fix those markdown files, add more functions to feeding the LLM, do whatever it takes to improve the results. Give online resources, fine-tune. And last, and I think this is the most important one, don't be afraid to mix and match. I would recommend that, especially in this time, that we're getting more familiar with how LLM works with those frameworks. Don't be afraid to go and basically experiment. Change your extensions, change your protocols. It really is just copy-paste of this text from one place to another, and in some fine-tuning. But this is important. This is what will give you best results. So that's it. Thank you very much. Please go and experiment and explore the world of AI. Thank you very much for listening.